Okay, so we have studied static pile capacity in the last lecture. Okay, so now we can study about dynamic pile capacity. Okay, so here this dynamic pile capacity is usually used for driven piles, and it is related to the efficiency of hammer. It is actually related to hammer and its efficiency, hammer blow, penetration, etc. during the pile driving operation. Okay, so the pile driving equipments used are hoist to lift the pile. There is a hoist to lift the pile, and device to hold the pile in position, and a device to provide impact energy. That is usually by using hammer we are providing impact on the pile, and cap block and cushion mounted on the pile head. And pile hammer, it may be a drop hammer, steam or pneumatic hammer, single acting hammer and double acting hammer, and diesel hammer, vibratory hammer. So different kinds of hammers are used for driving the pile. Okay, so this dynamic pile capacity actually relates to the efficiency of hammer, and this dynamic pile capacity is derived using an assumption, that is kinetic energy delivered by the hammer during the driving operation is equal to work done on the pile. So by equating the kinetic energy delivered by the hammer during driving operation by the work done on the pile, we have derived so many equations. Okay, so in your there are so much equations for this dynamic capacity, like engineering news formula, then Hairy's formula, and modified Hairy's formula. In your syllabus, modified Hairy's formula is only required, so I am explaining that equation only. Okay. So I have told that this equation is derived by equating the kinetic energy delivered by the hammer is equal to work done on the pile. So this ultimate bearing capacity QU is equal to, according to modified Hairy's formula, QU is equal to WH eta divided by S plus C by 2. This is the equation, that is modified Hairy's formula. Okay, that is here so many terms coming which is related to the hammer. So W is the weight of hammer. Okay, weight of hammer, and H is the blowing height, that is for how much height we are using the hammer blow. That is H is the blow height, and eta is the efficiency of hammer. Okay, and S is the penetration of pile per hammer blow. That is how much depth the pile is penetrated using the hammer blow, that is S. Okay, and C is a constant, and this constant varies with the type of hammer. So for drop hammer its value is 2.5, and for steam hammer it is 0.25 centimeter. Okay, and this efficiency, there is an equation for this efficiency, that is efficiency is equal to, that is this eta efficiency is equal to W plus PE square divided by W plus P for W greater than PE. That is, if W is greater than PE, efficiency equation is like that, and if W is less than PE, efficiency is equal to W plus PE square divided by W plus P minus 1 W minus PE by W plus P the whole square. And here P is a constant, it is known as coefficient of restitution. Okay, and this factor of safety is usually taken as 2.5. and E. So I have told that E is coefficient of restitution of a material under impact, and for steel ram of double acting hammer striking on steel anvil and driving reinforced concrete pile, E is 0.5. And for cast iron ram single acting or drop hammer striking on head on reinforced concrete pile, E is 0.4. And single acting or drop hammer striking on well conditioned driving cap and helmet with hardwood dolly in driving reinforced concrete piles or directly on head of timber pile, E is 0.25. Okay, so E is coefficient of restitution and its value is like this. So in problems it will be given. And C is a constant, and it's equal to C1 plus C2 plus C3, where C1 is the temporary compression of dolly and packing, C2 temporary compression of pile, C3 temporary compression of ground. And equation of C1, C2 and C3 is given, and by adding C1, C2 and C3 we will get C. C is a constant. Okay, so this is modified Hailes equation. So here this is the main equation, and efficiency is calculating using these two equations. So you should by heart these three equations. So we have to calculate P into E and also note weight and compare whether W is greater than PE or less than PE. So by checking this value, you choose the equation for calculating efficiency. Okay, if it is greater than, if W is greater than PE, efficiency equation is this, and if W is less than PE, this is the efficiency equation, and calculate this efficiency, substitute in this equation and calculate ultimate bearing capacity. Okay, so we can do one problem. Sorry. A RCC pile weighs 25 kilonewton. It is driven by drop hammer weighing 35 kilonewton, having effective fall of 0.8 meter. Average set per blow is 1.3 centimeter. Take elastic compression is 1.6 centimeter. Assuming coefficient of restitution as 0.25. Find ultimate and safe load on pile. Assume suitable factor of safety. So here W is given as, that is W is the weight of hammer and P is the weight of pile. Okay, so pile weight is 25 kilonewton, that is P is 25 kilonewton, and hammer weight is 35 kilonewton, that is W is 35 kilonewton. Okay, so first you write down the parameter which is given. Okay, then effective fall, that is height of fall, that is 0.85 h, and average set per blow is 1.3 centimeter. So it is actually average settlement per blow, that is average penetration per blow, or S. S is 1.3 centimeter. Okay, so this S means penetration of pile per hammer blow. Okay, so that is 1.3 centimeter, and elastic compression is 1.6 centimeter, that is C is 1.6 centimeter. So I have told sometimes C will not be given, so it is taken as C1 plus C2 plus C3. C1 elastic compression. Okay, and C1 means temporary compression of dolly, C2 temporary compression of pile, and C3 temporary compression of ground. So in this problem it's already given as C is given as 1.6 centimeter. Okay, so C is 1.6 centimeter. And coefficient of restitution as 0.25, that is E is also given as 0.25. Okay, so first you have to check whether W is greater than PE or less than PE. So calculate PE, that is P into E. P is the pile weight 25 into coefficient of restitution 0.25, that is 6.25 kilonewton. Okay, that is W. What is W? W is 35 kilonewton, that is, it is clear that this 35 is very much greater than 6.25, that is W is greater than PE. So since W is greater than PE, choose this first equation, that is efficiency is equal to W plus PE square by W plus P, and substitute the values. All the values are given. So eta is efficiency 0.61. Okay, then QP is equal to WH eta by S plus C by 2. Since all values are given, directly substitute these parameters, and answer is 863.3. And safe bearing capacity or safe load on the pile is equal to QP by factor of safety, and it is 345 kilonewton. Okay, so this is the procedure to calculate the dynamic pile capacity. Okay, so by heart this equation. So in your syllabus only this modified Hailes formula is there. So by heart these three equations. Okay, it's very simple. So if you you should do problems from your textbook, and if you have any doubt you can contact me. Okay, so this portion of calculating load capacity of pile is over. Thank you.